Hello and good afternoon friends, welcome to the CEC-UGC live lecture. Dear friends, in this session today we would be talking on naphthalene derivatives, and for this discussion we have once again with us in our studios Dr. Sushila Singhal. Dr. Sushila Singhal is Assistant Professor in Department of Chemistry, Deshbandhu College, University of Delhi. So let's welcome our guest Dr. Sushila Singhal and let's try to more and more on naphthalene derivatives. Hello ma'am, welcome to the CEC lecture.
Thank you Geetika ji. Good day to all viewers. Today in the series of polynuclear aromatic hydrocarbons and heterocyclic compounds, we are here to discuss with the derivatives of the naphthalene. In the last lecture, we already discussed the naphthalene aromatic hydrocarbon and many reactions on that hydrocarbon. After doing electrophilic substitution reactions and addition reactions of naphthalene hydrocarbon, we got many products which are called derivatives of the naphthalene. So in today's lecture, we will discuss about the naphthalene derivatives introduction, how substitution will take place in naphthalene derivatives, and we will discuss the hydroderivatives of naphthalene which are called naphthols. One of them is alpha naphthol and beta naphthol. We will do many reactions on these two naphthalene derivatives. Then we will study about the amino derivatives of naphthalene, that is alpha naphthylamine and beta naphthylamine. We will discuss their properties. And in the second module of this lecture, we will discuss about the naphthalene carboxylic acid and naphthaquinones, which are of many types. Then we will discuss some important conversions based on naphthalene hydrocarbon. Then we will discuss the naphthyl acetic acid and we will summarize today's lecture. So starting with today's lecture, naphthalene derivatives. In naphthalene derivative, first derivative is hydroxy derivative, in which we are having hydroxyl group on the alpha position, which is called alpha naphthol, and one of them is beta naphthol, in which electrophilic substitution of hydroxy groups take place at beta position. The second one is amino derivative. In the amino derivative, first one is alpha naphthylamine, in which amino group comes at alpha position, and the second one is beta naphthylamine, in which amino group will substitute the hydrogen at the beta position of the naphthalene hydrocarbon. Then comes naphthalene carboxylic acid. In the naphthalene carboxylic acid, this is a derivative which is formed by the addition of one carbon in the naphthalene ring, which will be done by the substitution reaction of cyanide and followed by hydrolysis. Then will come naphthaquinone, which is formed by the oxidation reaction of naphthalene. It can be of three types. It can be 1,4-naphthaquinone, 1,2-naphthaquinone and 2,6-naphthaquinone, which is also called as amphi-naphthaquinone. Now comes substitution in naphthalene derivatives. In case of naphthalene, the introduction of the second substituent into the naphthalene ring follows the same criteria as that of benzene. The nature of the group already present in the naphthalene will determine the position of the entering group, that the incoming group will come at which position. It follows three rules. In the rule 1, if the first group is ortho-para director in the benzene ring of the naphthalene hydrocarbon, it can be hydroxyl group, amino group and methyl group. If it is located at C1, then it will direct the incoming group to the C2 or the C4 position. In the rule 2, if the first group is at ortho-para director in the benzene ring is located at C2, it will direct the incoming group to the C1 position. As you can see in the reaction, that methyl group, which is already present in the naphthalene ring, is present at the carbon number 2, and after nitration the incoming group will come at carbon number 1. So this ortho-para directing group, it will direct the incoming group at the C1 position. If this C1 position is occupied and we will do the further nitration, then the next nitration will take place at next to the methyl group. It will take place at this carbon. Then the rule 3 says that if the first group is meta-director in the benzene ring, meta-directing group may be nitro group, sulfonic acid group, or it may be carboxylic acid group. It may be located at C1 or it may be located at C2, but it will direct the incoming group to the C5 and the C8 position which are present in the second ring. So, meta-directing group will direct the incoming group to the second ring of the naphthalene, and we will get here 1,5-dinitronaphthalene in case of nitration and 1,8-dinitronaphthalene. But the above rule do not always hold in all the substitution reaction as in sulphonation. In this case, the reaction is reversible, and at high temperature, sulphonation tends to take place at the beta position in either of these two rings of the naphthalene. We can follow this rule in one more reaction. For example, in case of naphthalene, if we do first chlorination in the naphthalene, then the incoming group, that is the chloro group, will come at the ortho position. And since this chloro group is ortho para-directing group, then further if we do the nitration on this chloro-naphthalene, then incoming group will come at ortho position or at the para position, and we will get ortho or para-nitro-chloro-naphthalene. But if first we do the nitration and then after nitration we do the halogenation or chlorination, since nitro group is meta-directing group, so first of all we will get alpha nitronaphthalene as a preference of electrophilic substitution takes place at alpha position. So, the nitro group first come at the alpha position. Now, if we do the chlorination on this nitronaphthalene, then incoming group will come at the meta position, since nitro group is meta-directing group, and we will get here meta-chloronitronaphthalene in this case. So, the position of the incoming group will be decided by the position of the already present group in the naphthalene. So, this will follow the naphthalene reactions. Now, we will start with the naphthalene derivatives. First of all, we will study about the hydroxyl derivative of the naphthalene, which is called naphthol. Naphthalene is having the molecular formula C10H8. So, one of this hydrogen has been replaced by the hydroxy group, and we will get the molecular formula C10H7OH. Now, this OH can be present at alpha position. It can be called as alpha naphthol or 1-naphthol. This hydroxy group can be present at beta position. It can be called as beta naphthol or it can be called as 2-naphthol. We have shown you the ball and the stick model of these two hydroxy derivatives of naphthalene. This is the alpha naphthol and this one is the beta naphthol. This alpha naphthol is a white solid fluorescent organic compound. It is present in coal tar along with naphthalene. This alpha naphthol is soluble in alcohol, ether and chloroform. It is a metabolite of insecticide carbyle and pharmaceuticals including nadolol. It is also used as biomarker for livestock and humans exposed to polynuclear aromatic hydrocarbons. Alpha naphthol dissolved in ethanol is known as Molish reagent, and this reagent is used for detecting the presence of carbohydrate in the systematic analysis of organic compound. In this reaction, this alpha naphthol react with carbohydrate to give the red color or the purple color compound. If we get red color, then it will give the positive test and we will say that the carbohydrate is present in the organic compound. With ferric chloride, it gives violet blue precipitate of alpha binaphthol, which is a complex. It is also used in the manufacture of insecticides and dyes. Alpha naphthol is also used in Sakaguchi test with sodium hyperbromide to detect the presence of arginine amino acid in proteins. We can also use this alpha naphthol in potassium hydroxide solution in Vogue's precursor test to detect the breakdown of glucose into acetone, in which a positive test is shown by the appearance of red color of the original yellow color. It means the yellow color will change into the red color and the breakdown of glucose into acetone. This acetone is used by the bacteria for external energy storage. So this alpha naphthol is naphthalene hydrocarbon can be prepared from sodium 1-naphthalene sulfonate. First of all, we have to prepare this sodium 1-naphthalene sulfonate, which can be prepared from naphthalene by sulfonation reaction. Here we will get sodium 1-naphthalene sulfonate, which on reaction with sodium hydroxide at 300 degrees centigrade will form sodium naphtha oxide, which on treatment with further dilute sulfuric acid will yield us the alpha naphthol. So we can get alpha naphthol from naphthalene by sulfonation followed by fusion with the alkali. Next important preparation of alpha naphthol is from naphthylamine, which is also prepared from naphthalene by nitration. First of all, naphthalene on nitration with nitric acid and sulfuric acid will give us 1-nitronaphthalene, which on reduction will give us aminonaphthalene, or you can say 1-naphthylamine. This 1-naphthylamine, after substitution on alpha position by the hydroxy group with the help of dilute sulfuric acid under pressure, will give us the alpha naphthol. We can also prepare alpha naphthol from orthobromofluorobenzene. This orthobromofluorobenzene on reaction with lithium amalgam in the presence of a hetero compound furan will give a intermediate, which on reaction with hydrochloric acid will give us the alpha naphthol. This reaction proceeds via benzene mechanism. In the first step, benzene is formed. This benzene intermediate is formed, which will react with furan to form this adduct. This adduct on reaction with mineral acid will give us the alpha naphthol. Now comes the chemical properties of alpha naphthol. Alpha naphthol resembles phenol in its chemical properties. It is a hydroxy derivative of naphthalene as the hydroxy derivative of benzene, which is called phenol. So like phenol, it is also acidic in nature. It is a weak acid. It dissolves sodium carbonate and sodium hydroxide to form water soluble sodium alpha naphthoxide. You can see in the reaction here, this is the alpha naphthol. It reacts with sodium hydroxide to give us the sodium 1-naphtha oxide. This is a weak acidic hydrocarbon. It ionizes in water to give us the resonance stabilized naphthoxide ion. Alpha naphthol is stronger acid than phenol due to its greater stability of this naphtha oxide ion, in which we are having the negative charge, which is localized on 2 benzene ring as compared to the phenoxide ion. In case of phenoxide ion, this negative charge is distributed over 1 ring only, while in case of naphtha oxide ion, it is distributed over 2 benzene rings. So more the distribution of the negative charge or the delocalization, the more will be the stability of the intermediate, and more will be the nature of that acidity of alpha naphthol. Now when the sodium 1-naphtha oxide is treated with alkyl halide, the corresponding ethers are formed. This is also called as the name reaction, which is called as Williamson synthesis. It takes place in phenol also. When phenol reacts with alkyl halide, they also form ethers. Like phenol, naphthalene also forms ethers in case of reaction with alkyl halide. You can see in the reaction here, on reaction with ethyl iodide, it forms ethyl 1-naphthyl ether. This alpha naphthol can also react with phosphorus pentaoxide, and here chlorination takes place. Chlorination of naphthalene after substitution of hydroxy group with the naphthalene, we will get here the 1-chloronaphthalene. Then comes the Bucherer's reaction. This Bucherer's reaction is very important reaction since it is the reversible conversion of naphthol into the corresponding naphthylamine. We have shown in the preparation also that this naphthol can be prepared from the naphthylamine, so it is the reversible reaction of that preparation. We can prepare this naphthylamine on reaction of 1 naphthol with ammonia and ammonium sulphite at 150 degrees centigrade under pressure, and we will get here 1 naphthylamine. Then comes azo coupling. 1 naphthol reacts with benzene diazonium chloride in a weakly alkaline solution at 0 to 5 degrees centigrade to give us 4-phenyl azo 1 naphthol. This reaction takes place in ice or at 0 degree temperature. In this reaction, naphthalene undergoes coupling with benzene diazonium chloride and it gives us this azo product. Then comes reaction with nitrous acid. Alpha naphthol reacts with nitrous acid to give us 2-oxime of 1,2-naphthaquinone. On reaction with nitrous acid, this oxime is formed. First of all, this hydroxy group undergo enolization and then it will form 2-oxime of 1,2-naphthaquinone. Now comes sulphonation reaction. 1 naphthol reacts with concentrated sulfuric acid at 40 degrees centigrade to give us a mixture of 2 products. One of them is 1 naphthol sulfonic acid, which is also called as Schaeffer's acid, and 1 naphthol 4-sulfonic acid, which is called Neville-Winther's acid. Both of these acids formed are used in the manufacture of organic dyes. Here sulphonation takes place at ortho position of the hydroxy group already present in the naphthalene, and here sulphonation takes place at the para position since this hydroxy group is ortho para directing group. So we will get here the ortho and the para product of sulfonic acid. Now comes the nitration of alpha naphthol. Alpha naphthol reacts with nitrating mixture, which is concentrated nitric acid and sulfuric acid at 20 degrees centigrade to form 2,4-dinitro-naphthol. This is 2,4-dinitro-naphthol. Sodium salt of this 2,4-dinitro-1-naphthol is also called as Marty's yellow, which is used as a commercial dye for wool and silk. So this reaction is very important for industrial preparation of dyes. Now comes a reduction reaction. 1 naphthol undergoes reduction with lithium metal in liquid ammonia to yield 5,8-dihydro-1-naphthol. This is a name reaction which is called as Birch reduction. So alpha naphthol on Birch reduction will give us the 5,8. This is the 5 and the 8. Hydrogens are adding on these two positions and we will get dihydro-1-naphthol. Reduction of 1-naphthol can also take place with sodium and isopentanol, and we will get here AR tetrahydro-1-naphthol. This AR, it stands for aromatic and it indicates that the 4 hydrogens which have been added are not in the ring which contains the hydroxyl group. So these hydrogens which are added by reduction has been added in the second ring which do not have hydroxyl group. So its name is AR tetrahydro-1-naphthol or AR alpha tetralol. Then comes the oxidation reaction of alpha naphthol. Alpha naphthol reduces ammonical silver nitrate since it oxidizes itself to form quinone. It is oxidized by chromium trioxide in the presence of acetic acid to give 1,4-naphthaquinone, and by alkaline potassium permanganate to give naphthalonic acid. It can also undergo oxidation with the help of ferric chloride. On reaction with ferric chloride, it yields a blue-violet precipitate of 4,4-bis-1-naphthol, which is also called as alpha binaphthol. This structure is alpha binaphthol, which is having a blue-violet precipitate. So it can be used as a test reaction for alpha naphthol. If the unknown product forms this blue-violet precipitate with the ferric chloride, then we will see that the unknown compound is alpha naphthol. Now comes the beta naphthol, the second derivative, second hydroxy derivative of naphthalene. It is also a colorless crystalline solid which is slightly soluble in water but soluble in alcohol, ether, chloroform and other organic solvents. It is used for making Sudan dyes. This beta naphthol is used as antioxidant in the manufacture of synthetic rubber. It is also used as antiseptic in the treatment of skin diseases, but when this alpha naphthol is inhaled or it is swallowed, it is very dangerous, it is very harmful to the ecosystem, especially to the aquatic ecosystem for the fishes. It is also used for preparing its methyl and ethyl ethers, which are called as narrolines, which are extensively used in perfumery industries. Now comes the preparation of this beta naphthol. Beta naphthol can also be prepared from the sodium 2-naphthalene sulphonate, which can be prepared from naphthalene by sulphonation. Sulphonation of naphthalene at high temperature will give us the beta naphthalene sulphonic acid. Sodium salt of this beta sulphonic acid, which is called as sodium 2-naphthalene sulphonate, on treatment with sodium hydroxide at 300 degrees centigrade will first give us the sodium 2-naphthoxide. This is sodium 2-naphthoxide, which on treatment with dilute sulfuric acid will give us the 2-naphthol, and we will get here the beta naphthol by the sulphonation reaction. Now comes the chemical properties of this important compound beta naphthol. First of all, it is acidic in character. Like alpha naphthol, it is also a stronger acid than phenol. It dissolves sodium carbonate and sodium hydroxide to form water soluble sodium 2-naphthoxide. It is again a stronger acid since this naphtha oxide, the negative charge of this naphtha oxide is distributed over 2 rings of naphthalene, while in case of phenol it is distributed only on the 1 ring, so it is more stronger acid than phenol. When the sodium 2-naphthoxide is heated with alkyl halide, we will get the corresponding ethers, which is called Williamson synthesis. Here in this case, this sodium 2-naphthoxide, this is sodium 2-naphthoxide, when it is treated with ethyl iodide on heating, it will give us the ethyl 2-naphthyl ether. This is ethyl 2, this is naphthyl, this is the ether linkage. So we will get here 2-ethoxynaphthalene. This 2-ethoxynaphthalene is known as narrolin, and it is used as a perfume in artificial neroli oil and the eau de cologne substance. Then comes reaction with the phosphorus pentachloride. 2-naphthol also reacts with phosphorus pentachloride to form 2-chloronaphthalene. Here the substitution of chlorine will take place at the 2 position since hydroxy group in the naphthalene present at the 2 position, so it will be substituted at 2 position only, and we will get here the 2-chloronaphthalene. Now comes a Bucherer's reaction. 2-naphthol reacts with ammonia and ammonium sulfite at 150 degree centigrade under pressure will give us the 2-naphthylamine product. It is again a reversible reaction. We can also form 2-naphthol from the 2-naphthylamine, and here in this case we are getting here the 2-naphthylamine from 2-naphthol. Then comes the azo coupling. 2-naphthol also reacts with benzene diazonium chloride in a weakly alkaline solution at low temperature or in ice at 0 to 5 degree temperature to give us 1-phenyl azo 2-naphthol. This is 1-phenyl azo 2-naphthol. This is a coupling reaction in which we are having coupling at the ortho position of the hydroxyl group already present, and we will get here the coupled product at the carbon number 1. Here the incoming group, which is ortho para directing group, it is present at the C2 position, and we are having the incoming group at the position number 1, and we will get here the substituted product which is called 1-phenyl azo 2-naphthol. Now comes the reaction with the nitrous acid. 2-naphthol on reaction with nitrous acid will give us 1 oxime of 1,2-naphthaquinone. Here this 2-naphthol on reaction with nitrous acid will give us the 1 oxime of, this is 1,2 position of naphthaquinone, and we are getting here the oxime at this carbonyl compound of naphthalene, in which the carbonyl group is present at C1 position. So we are getting here oxime at the C1 position of the 1,2-naphthaquinone. Now comes the sulphonation reaction. Beta naphthol reacts with concentrated sulfuric acid at 2 different temperatures. At 40 degree centigrade sulphonation takes place, and we will get here the 2-naphthol 8-sulfonic acid. This 2-naphthol 8-sulfonic acid is also called as Crocean acid, and when the reaction is carried out at 100 degree centigrade, this Crocean acid undergoes rearrangement to give 2-naphthol 6-sulfonic acid, which is also called as Schaeffer's beta acid. Both of these 2-sulfonic acid are used in the manufacture of azo dyes. So this sulphonation reaction of beta naphthol is commercially used since we are getting the product which are used in the dye industries. Then comes the oxidation of beta naphthol. Beta naphthol also reduces ammonical silver nitrate. It oxidizes itself and it reduces the silver nitrate solution. It is oxidized by alkaline potassium permanganate, which is also called as Bayer's reagent, to give us phthalenoic acid. In this reaction, we are getting oxidation product in which one of the naphthalene ring has been damaged or has been oxidized at these 2 carbons which are present at ortho positions, and we will get here phthalenic acid. This alpha naphthol can also undergo oxidation with the ferric chloride. On reaction with ferric chloride, we are getting blue-violet precipitate of 4,4-bis-2-naphthol, which is also called as binol. This is the complex which is called as binol. Here 2 molecules of beta naphthol will fuse together in the presence of ferric chloride, and we are getting here beta binaphthol, which is called as binol. This binol is often used as a ligand for transition metal catalyzed asymmetric synthesis. This binol is having the axial chirality, and the 2 enantiomer or these 2 isomers can be readily separated, and after separation they are stable towards racemization. This alpha naphthol can also undergo reduction reaction. On reduction with sodium and isopentanol, it gives us AC tetrahydro 2 naphthol. This AC, it stands for alicyclic, which indicates that the 4 hydrogen atoms are present in the ring containing the hydroxyl group. It means the reduction is taking place in that ring of naphthalene in which we are having the hydroxyl group present, and we are getting here the AC beta tetranolone. So the reduction will take place at the ring, second ring, in which we are already having the substituent. These two molecules of hydrogen are added to C1 and the C4 position of naphthalene. So this was all about the reactions of alpha naphthol and beta naphthol. Thank you. Now after the hydroxy derivative, now comes the amino derivatives of naphthalene. These naphthylamine or aromatic amines are colorless solids. It turns brown on exposure to air. This naphthylamine is only slightly soluble in water and again soluble in organic solvents like ethanol, ether, chloroform and carbon disulfide. It has unpleasant odor. This naphthylamine are used in the manufacture of dyes. Now comes the preparation of naphthylamine. First of all, we can prepare this naphthylamine by the reduction of 1 nitronaphthalene with iron and hydrochloric acid. In this case, 1 nitronaphthalene, we are reducing this nitro group and we are getting here this amino group at the position number 1, and we are getting here 1 naphthylamine. This 1 naphthylamine can also be prepared from ammonium sulfonate at 150 degrees centigrade under pressure. Further, this naphthylamine can also be prepared by heating alpha naphthol with zinc chloride at 260 degrees centigrade. Here in this reaction we have shown alpha naphthol on reduction with ammonia, and on the right side we have shown the reaction with the ammonia sulfate under pressure, and we are on both sides we are getting 1 naphthylamine. Now comes the chemical properties of naphthylamine, alpha naphthylamine, which is basic in character. It is a weak base with a pKa value of 3.9. It dissolves in acid to form the corresponding salts. The reason behind the weak basicity of alpha naphthyl is that the lone pair present on nitrogen is involved in the formation of delocalized pi molecular orbital and is not readily available for donation. or for the formation of new covalent bond with protein. Here in the reaction, 1-naphthylamine on reaction with hydrochloric acid or any other mineral acid will form the salt, and here we are getting the 1-naphthyl ammonium chloride. This 1-naphthylamine is weaker base than aniline. Since aniline is having the pKa value of 4.6, why it is so? This in case of aniline, this lone pair present on amino group is available only available for the delocalization of only one ring. So it is a stronger base. These electrons are free to donate, but in case of 1-naphthylamine, these lone pair present on ammonia or amino group present on naphthalene is delocalized over two rings. This one ring and this is shown a little bit attached, since it is localized on the second ring also, and delocalization takes place in two rings. So these lone pair is not available for donation, since basicity is the property in which the lone pair is easily donated. So the compound will be more basic. So in case of naphthylamine, it is lesser basic than aniline. Now comes a diazotization reaction. 1-naphthylamine, it reacts with sodium nitrite in excess hydrochloric acid at 0 to 5 degrees centigrade, and it first forms the 1-naphthyl diazonium chloride, which further forms many compound. If this naphthalene diazonium chloride further reacts with many compounds like chloro compound, bromo compound, fluoro compound, cyano compounds, then we will get their respective hydrocarbons or respective compounds. Like other diazonium salts, this naphthalene diazonium chloride, when it reacts with copper bromide, we will get here the 1-bromonaphthalene, which on reaction with magnesium and ether will give us the 1-naphthyl magnesium bromide. It is formed like a Grignard reagent. This is RMgX. So Grignard reagent can be prepared from this method also, and by hydrolysis of this product we will get the many compounds, we will get the corresponding many compounds. Then comes the azo coupling of 1-naphthylamine. This 1-naphthylamine on reaction with benzene diazonium chloride in a weakly alkaline solution on reaction with sodium hydroxide at 0 to 5 degrees centigrade will give us the coupling reaction at 4th position, since this amino group is ortho-para directing group. If the substitution will take place at ortho position, then it will be a crowded compound and it will be less stabilized. So the incoming group will come at the 4th position and we will get the more stable 4-phenyl azo 1-naphthylamine. Now comes the sulphonation. 1-naphthylamine on reaction with concentrated sulfuric acid at 140 degrees centigrade will give us naphthionic acid. This is naphthionic acid in which sulphonation will again take place at para position, since amino group is ortho-para directing. If the incoming group, sulphonic acid group, will come at the ortho position, this sulphonic acid group is bulky in nature, then again steric hindrance will take place in the molecule and it will unstabilize the molecule. So the incoming group will come at the para position in this case, and we will get here the naphthionic acid. This is used in the manufacture of Congo red dye. Then comes a reduction reaction. 1-naphthylamine, it undergoes reduction with sodium and isopentanol to give us AR tetrahydro 1-naphthylamine. This AR stands for aromatic ring and will introduces that the incoming hydrogens, the reduced ring will be the one in which we are having not having the amino group already present. Then comes the oxidation reaction of naphthylamine. Naphthylamine also reduces ammonical silver nitrate, and it can again undergo oxidation with chromic trioxide in acetic acid to give us 1,4-naphthaquinone. This is 1 and this is the 4 carbon, and we are getting 1,4-naphthaquinone. While if this oxidation is carried out in the presence of potassium permanganate in alkaline medium, it will give us the phthalic acid, in which one of the benzene ring of the naphthyl main nucleus is destroyed, and we are getting here the phthalic acid. Then comes the second derivative of amino, naphthalene derivative, which is called as 2-naphthylamine, or it can also called as beta naphthylamine. It is also basic in character with the pKa value of 4.1. It also dissolves in acid to form the corresponding salt. Since it is basic in nature, it reacts with mineral acids like hydrochloric acid. It will form 2-naphthyl ammonium chloride. This salt is formed in this reaction. Now comes a diazotization reaction of 2-naphthylamine. This 2-naphthylamine, it reacts with sodium nitrite in excess of hydrochloric acid at 0 to 5 degrees centigrade or in ice to yield 2-naphthalene diazonium chloride. Here we are getting diazonium chloride coupling at the position number 2, since we are having the amino group already present at the 2 position. So, substitution will take place at the same position. Now comes the azo coupling. 2-naphthylamine reacts with benzene diazonium chloride in the presence of sodium hydroxide at 0 to 5 degrees centigrade. Here we will get 1-phenyl azo 2-naphthylamine, since we have already said that this amino group is ortho-para-directing group, and this incoming group will decide the position of the entering group, and here again the entering group will come at the C1 position, and we will get here 1-phenyl azo 2-naphthylamine. Now comes the reduction reaction. 2-naphthylamine on reduction with sodium and isopentanol will give us AC tetrahydro 2-naphthylamine. This AC stands for aliphatic ring, and here after reduction we are getting the reduced product, in which reduction will take place in that ring in which we are having the amino group. So, it is now become the aliphatic ring. So, the product is named as AC tetrahydro 2-naphthylamine. Then comes the oxidation reaction of 2-naphthylamine. It also reduces ammonical silver nitrate, which is called as Tollens reagent. It is oxidized by alkaline potassium permanganate called as Bayer's reagent to give us the phthalic acid. Here the oxidation is taken place in that ring in which we are having the amino group. So, we will get here the oxidized product phthalic acid, which is also used in the dye industries. The second more important naphthalene derivative is naphthalene carboxylic acid. This naphthalene carboxylic acid can be alpha, it can be beta. So, it is alpha or beta naphthoic acid. These can be obtained by the hydrolysis of corresponding cyanides or naphthyl magnesium bromide or acetyl compounds. This is the alpha naphthoic acid, since we are having this cyano group present at the alpha position. So, after the hydrolysis of one cyano-naphthalene, we are getting here alpha naphthoic acid. If this cyano group is present at the C2 position, it will be 2-cyano-naphthalene, and after hydrolysis of that 2-cyano-naphthalene, we will get here the beta naphthoic acid. This alpha naphthoic acid, it can also be prepared from the naphthalene magnesium bromide on reaction with carbon dioxide in the presence of ether, a volatile solvent. It can also be prepared from 1-acetyl naphthalene on reaction with sodium hypochlorite. Sodium hypochlorite is used as a oxidizing agent in this reaction, and we will get here the alpha naphthoic acid. If these two already present group are present at the C2 position here, then again we will get here the beta naphthoic acid. Now comes one more important derivative of naphthalene, which is called naphthaquinone. Since naphthaquinone, 6 naphthaquinones can be possible theoretically, but out of these 6 naphthaquinones, 3 isomers are known which are present naturally. One of them is called as 1,4-naphthaquinone, since these 2 carbonyl groups are present at 1 and the 4 position. One of them is 1,2-naphthaquinone based on the position of the carbonyl groups, and it can be 2,6-naphthaquinone since these are at the 2 and the 6 position. This third isomer is also called as amphi-naphthaquinone. Now comes the 1,4-naphthaquinone preparation of this isomer. It can be obtained by the oxidation of 4-amino-1-naphthol. This is 4-amino-1-naphthol on reaction with potassium dichromate in the presence of sulfuric acid or any other acidic medium. We will get here 1,4-naphthaquinone. Oxidation will take place at 1 and the 4th position, and we will get the product. This 1,4-naphthaquinone can undergo reduction to give us 1,4-dihydroxylnaphthalene. These 2 ketonic group or these 2 carbonyl group will reduce their self in the in the presence of hydroiodic acid, and with the red sulfur will give us the reduced product, which is called 1,4-dihydroxylnaphthalene. This 1,4-naphthaquinone, it can also undergo oxidation reaction. Oxidation of this 1,4-naphthaquinone in the presence of potassium permanganate in acidic medium with dilute sulfuric acid will give us the phthalic acid. Here the oxidation is taking place at these 2 ortho position of naphthalene, and we will get oxidized product, here the phthalic acid. This 1,4-naphthaquinone derivative is also present in many natural forms. One of them is juglone, which is called 5-hydroxyl, in which hydroxy group is present at 5 position of the 1,4-naphthaquinone nucleus. It occurs naturally in the leaves, in the roots, husk, fruits and bark of the Juglandaceae family, particularly the black walnut. It is very toxic and it stunts the growth of other plants. So, since it inhibits the growth of other plants, it is also used as a herbicide and also a hair dye for cloth and ink. Then these are again 2 natural forms of 1,4-naphthaquinone derivative. One of them is plumbagin and one is lawson. Plumbagin is a yellow dye which is having antimicrobial, anti-inflammatory and neuroprotective effects. So, it is very important dye. Then comes the lawson. This lawson, it is again a hydroderivative of 1,4-naphthaquinone, which is a red-orange dye present in the leaves of henna plant, which is called the mehndi. It reacts chemically with the keratin protein in skin and hair in a Michael type addition reaction, resulting in a strong permanent stain, and it will last since the growth of the hair, and it will stay for 2 to 3 weeks, then it will shed off. This 1,4-naphthaquinone is also present in vitamin K, which is found in leafy vegetables and is essential for the proper coagulation of blood. It is a derivative of 2-methyl-1,4-naphthaquinone, which is called as menadione. This is the vitamin K, in which this is the extensive part of methyl chain, and we are having this 1,4-naphthaquinone, the main nucleus, main skeleton of vitamin K. Then comes the second isomer of naphthaquinone, which is 1,2-naphthaquinone. This 1,2-naphthaquinone can be prepared by the oxidation of 1-amino-2-naphthol. This is 1-amino-2-naphthol on reaction with ferric chloride in the presence of hydrochloric acid will give us the 2 ketonic group at the 1 and the 2 position, and we will get here the 1,2-naphthaquinone. This 1,2-naphthaquinone isomer, it can undergo reduction reaction. It is a red crystalline solid which is non-volatile with steam. It can be reduced with hydroiodic acid alone to give us 1,2-dihydroxyl naphthalene. Here the 2 ketonic group which are present at the 1,2 position of naphthalene, these two are reduced, and since this ketonic group reduces to give us the hydroxyl group, we will get here the product 1,2-dihydronaphthalene. This 1,2-naphthaquinone isomer of naphthaquinone can also undergo oxidation reaction. On oxidation with potassium permanganate and dilute sodium bicarbonate solution will give us the naphthalonic acid. Here the oxidation will take place at these 2 carbons, carbon number 1 and the carbon number 2, these fused 2 carbons. Second ring of this naphthalene will oxidize to give us phthalonic acid. Now comes the third isomer of naphthaquinone, which is 2,6-naphthaquinone, also called as amphi-naphthaquinone. It is prepared from 2,6-dihydroxynaphthalene. It undergo oxidation in the presence of activated lead dioxide in the warm benzene, and we will get here oxidation product which is called 2,6-naphthaquinone. It is a orange solid. Now based on this naphthalene, there are some conversions based on the chemical electrophilic substitution reaction of naphthalene. If we have to convert this naphthalene into 4-amino-1-naphthol, what we have to do in this case? First we will do the nitration on the naphthalene ring, and here on reaction with nitric acid and sulfuric acid, we will get the nitration at the alpha position of the naphthalene, and we will get here the 1-nitronaphthalene. This 1-nitronaphthalene on reduction with tin and hydrochloric acid will give us the amino derivative, will give the 1-amino-naphthalene, which on reaction with nitrous acid, this amino group will be substituted by the hydroxyl group, and we will get here the 1-naphthol. Now 1-naphthol we have got. Now we have to introduce the amino group at the 4th position. So the 4th position of this 1-naphthol is the para position. So to allow the entering of amino group at the 4th position, first we have to react this 1-naphthol with the benzene diazonium chloride, and here after reaction with benzene diazonium chloride we will get the diazonium salt, which on reduction with tin and hydrochloric acid will give us the 4-amino-1-naphthol. So starting from naphthol, we have added here the 2 substituent at the carbon number 1 and the 4 via these 4-5 steps. In the second conversion, we have to convert this naphthalene into 1,4-diamino-naphthalene. Now we have to introduce here 2 amino group. So for the introduction of 2 amino group, we have to do first the nitration on the naphthalene, then it will be followed by the reduction reaction. So in case of nitration at naphthalene, nitrating mixture is used. In the second step, reduction is done in the same step, and we will get here the 1-amino-naphthalene. Now to allow the second substituent in the same ring, first we have to do the protection of this amino group. So for the protection of this amino group, we can use here the acetic anhydride, and we will get here the acetyl derivative of this 1-amino-naphthalene. Now this already present amino group has been protected, and the further nitration will take place at the either at the ortho position or at the para position of the acetyl derivative. Now since ortho position is if the incoming group will come at the ortho position, it will be a little bit unstable. So we will get here the para derivative. Nitro group will come at the para position, and reduction of this para nitro acetyl derivative followed by hydrolysis will give us the 1,4-diamino naphthalene. Naphthalene can be converted into 4-amino 1-naphthalene sulfonic acid. So here we have to add 1 amino group and 1 sulfonic acid group. So first we will do the nitration followed by reduction. By doing the nitration, we will get here the nitro group introduced in the naphthalene, and on reduction it will reduce to amino group. Now amino group has been introduced. Now we have to do the sulfonation of this amino naphthalene, and we will get the sulfonic acid group at the para position. Since if it will take place at ortho position, it will be unstabilized. This naphthalene can be converted into alpha naphthyl carbinol, which is called as naphthalene, in which the substituent is CH2OH. Here we have to add one more carbon to the naphthalene ring. For adding one more carbon, we have to use the formaldehyde or any chloromethylation reaction. So for this we have to first introduce the halogen in the naphthalene ring, which is done by the Friedel-Crafts reaction. This is a bromo derivative we are getting by bromination in the presence of ferric bromide, and on reaction with magnesium and ether we will get here the magnesium bromide naphthalene, which on reaction with formaldehyde followed by hydrolysis with water we will get here the carbinol, which is introduced at the alpha position of the naphthalene, and here we will get the alpha naphthyl derivative. One more important derivative of naphthalene is alpha naphthyl acetic acid. This alpha naphthyl acetic acid is obtained by chloromethylation of naphthalene, which can be made by converting this nitrile followed by the hydrolysis. Here we have taken naphthalene, which on chloromethylation in the presence of hydrochloric acid will give us a 1-chloromethyl naphthalene. Now we have to add one more carbon in this adduct, since we have to make it acetic acid. So for this, first of all, we will do the electrophilic substitution with the potassium cyanide. We will get here CH2CN nitrile derivative, which on reduction, which on hydrolysis will give us the acetic acid, and we will get here the alpha naphthyl acetic acid. This alpha naphthyl acetic acid is of very commercial importance, since it is used as apple set spray to reduce the premature of dropping of the fruit from the tree. One application near the end of the growing season holds the apples on the tree for 1 to more weeks. It is used as a preservative in this case. Alpha naphthyl acetic acid is also used as a spray to delay the flowering of fruit tree until the danger of frost is past. It is also used as a spray to keep potatoes from sprouting. And when this alpha naphthyl acetic acid is sprayed on tomato and cucumber, it causes the production of seedless fruits. So from the point of industrial application, this alpha naphthyl acetic acid is very important in the preservation of food, since we can stop the dropping of fruit, we can get the desired fruit at a proper time in which ripening of the fruit will take place on the tree only, and we can also prevent the potato sprouting, or we can preserve the food. So these naphthalene derivatives are important in case of dyes, in case of pharmaceuticals and many more industries. With this, some questions are there based on the lecture, in which few conversions are there we have already discussed. Thank you.
With this note, thank you, ma'am. Thank you so very much. And dear friends, if you have liked today's lecture or if you have any queries, then you can mail us at info.cc@nic.in. We would be meeting again soon. Till then, take care. Goodbye. Thank you, ma'am. Thank you so very much.